Hi, today we will combine the previous two episodes together, and this is a hands-on practice. We'll create an API which will be a game guess the number. The computer thinks of a number between like 1 and 100, and you have to guess it. And how many tries you have, you are the better. So let's just crack on. Now let's crack on with the game. I already have a main function. So what we will have to do, there's going to be an API call, and the API call can send you a GET request. If it's a GET request, it means there's a new game. The computer will think of a new number. If it's a POST request, in the POST request body, it will accept as JSON with your guess. And if your guess is like bigger than the number was thought by the game, then it will display bigger is a JSON, and if it's smaller, it will display smaller, and if it's the identical, you just won, and it will count how many tries you had. So let's see what we need for this. Of course, we will need a handler here, an HTTP server. Also, we need a handler to decide or route if it is post or get. We need a handler for the get new game. We will need a handler for the post as a guess, your guess. And we need to initiate the game. Alias guess the number. The API can return with different statuses. So let's start by defining the statuses. Const status bigger equals bigger, status smaller equals smaller, status okay when you had a good guess. Yeah, so these are the statuses what we have. We can have a request and a response. The request is your guess. It will be a very simple struct. So type and guess request. It will be a struct, and it's just your guess. So guess, and it's an integer, and let's say we need a JSON tag. You remember for previous lesson, JSON guess, if I don't want to use the capital case. Okay, what we can respond with, type guess response as a struct, and we can, there's a missing letter, we can respond with the status. That's going to be a string with one of those values above. JSON and status. And we also need to respond with how many times we have tried, like tries, string, and JSON tries. Let's fix the typo. Okay, we have the structures. I have a missing quote here, and I also need something where I'm counting the guess numbers, how many tries we had globally, and also need to have the guessed number globally. So let's create another struct, which will be the guess struct. with two properties. It can be private because it's just internal use, which will be the number which the computer came up with, integer, and the thrice, which will be also an integer. Okay, let's define a global variable type. Let's call it random guess, which will be a guess. Okay, I will not just add a comment here, but we will not deal with this today. We will deal with this in a later episode. We need to make it thread safe, and I need to lock this for multiple user and risk conditions. But this is a next episode later in this course, not the immediate next episode. Okay, so let's just start implement those what I've commented. Spin up a HTTP server. HTTP server can return with an error, so I handle the error as well. If error HTTP listen and serve. Let's use port 8080, and by default no handlers. And if the error is not nil, just print what's the error, and that's it. Display on the screen what is the error, and display also on the screen that the server is running. fmt print line server is running on port 8080, just to know. Okay, first one I will implement is the initiate a new game. Let's create a function init game, and the init game will initiate this variable I defined here, random guess, which will be a guess. Sorry, I made a mistake because this is not a type, it's a variable. So random guess is a guess where the number will be a rand int n. The int n will give me a number if I say 100 between 0 and 99, but I don't want to have the number 0 as an option, so let's say +1. And as we know, by default, if I'm not providing the count, the thrice, it will be 0, but I will provide it just for readability, which is 0. And let's display this just for easier debugging. fmt print line number to guess, and this is the random number, random guess, and none. Okay, so let's initiate the game, and we already generated a random number and reset the time thrice to 0. Okay, the next one, what we said we need to do, we need to have a handler which will decide which another handler I will route to, depending on if it's a get or a post request. As you remember how we create handlers, func, and this is the game handler, which takes two parameters, the writer, response writer, which is HTTP response writer, and the request, which will be a pointer to HTTP request. I can immediately map this handler. So HTTP handler func. Let's map it just for simplicity directly. And game handler. Okay, so game handler have to decide where do we route forward depending on get or post. It's easy because I say if the request method equals HTTP method get, and I will route it to the get one and return, copy this one, and if it's post, then route it to the post one and return. If none of them, I just have a bad request. So let's return with a bad request, HTTP status with HTTP error. I can respond to the response writer. I will leave this empty. This is an optional string. HTTP status bad request. Because the bad request like speaks for itself, I will just keep it as it is without anything, any message. Okay, so let's implement the two handlers. First, it's easier if I just copy this because it's the same instruction, just need a different name. And this is the new game handler. And another one will be not cage but game. The another one will be the guess handler. We can now call them new game handler and passing response writer and request, and guess handler, and I'm passing response writer and the request. Okay, I have the body, and now let's implement those. New game handler, the only thing what it will do, it will initiate a new game. So I just call this initiate game, and I'm not planning to return with anything. For this, I will change the response status code to with the response writer right header HTTP status accepted. So it will just like return with an accepted status code. Okay, the new game handler is done. Now let's go to the post, which is the most important part, where we will use the JSON to populate those fields. But before we do that, if I'm working with APIs which are returning and requesting JSONs, it's always a good practice to output a JSON header, a content type JSON header. So let's start with that. We can do it in the following way. I use the W header and set content type, which is an application /JSON. This way the browser or the API which consumes my, or frontend which consumes my API will know that's requesting or responding with JSONs. Okay, the next one I have to do, I need to define a struct with the request. So I just copy this, and the request will be a guess request struct type, but this is currently not defined yet, so I need to marshal the data from the request body to it. There's a different way. So if I'm dealing with JSONs, I could like convert this request body to a string or a byte slice and use the previous lessons JSON convert marshal and unmarshal. But if we are dealing with response writers, we have a different way to do that, which is more effective. I can use the response writer directly. Let's see how we do that. So if I say if JSON, sorry, it can return an error. If I say if error equals JSON new decoder, and I can provide an IO reader, and the IO reader will be something in the request object, request struct called body, and decode, sorry, and I'm going to decode it to the request. And because I will change the request, I need to use a pointer. So that's request. And if there's an error, I don't need the if here. So if there's an error, just return an HTTP error, HTTP error, response writer. And this is probably a bad request because it it was not able to like marshal into the struct. So HTTP bad request, status bad request, and early return, because I don't want to continue working on this. There's another important thing. If I'm reading the body, it's good practice always to close that body, so I can use the defer keyword and air body close. Alright, so I have in the request object the guess. This is what I can work with. Let's create the response now. We called the response guess response. Let's copy that. Resp should be guess response. But before we do that, we need to increment the counter in the global variable, which is called random guess. So random guess tries plus plus, it will increment the guess counter, and I can immediately provide the tries here from the random guess tries. It looks like it's complaining. Let's see why. Random guess tries integer, and guess integer tries, it should be integer here as well. Okay, so I have the basic response. Now decide what comes into the status. And if I say if random guess number identical to my request guess, then the response status will be, we defined above, status okay. If random guess number bigger than request guess, then the status will be resp status equals status bigger, otherwise it will be status smaller. Okay, so I have the response ready to send. Let's see how will I send this out. I can use the JSON again, similar way like I did here with the new decoder. I'm just going to call the new encoder. So if air JSON new encoder, but I can provide the EO writer, and I can give an encode, call the encode function. I can pass what I want to encode, which is the response I previously defined. I don't need to use the pointer here because it will not be modified. So if the error, not nil, something went wrong, then I can return with an error, HTTP error, with the response writer. I will say something went wrong, and HTTP internal server error. Okay, so if something goes wrong, then I just return the error. Otherwise, this one will put to the response writer the proper response. And in theory, the application is done, so we just need to test it. For the test, I will use Postman. First, let's open a terminal and run the application. Go run dot. It's guessed the number 57. I have the Postman, and there's a get call to IT-Atti localhost. If I send this, it returns with a 22 accepted, which was okay, and there's a new guest, new game. On the other screen, I press the send again, and I have a new game. Now the number is 95. I send again. Now it's 55. It's a nice number to play with. I also have a post request. In the post request, I've created a body already for you, which is my guess, which is now like 80. Let's see what we need to find out. 55. So if I send, then it says smaller, and I've tried once. Then let's try like 10. It says it's bigger, and I've tried it twice. Let's try 70. It says smaller. I've tried 3 times. Let's try 50. It says it's bigger. Let's 60. It's smaller. And let's 55. And it's a good guess. So my application works. Yeah, this API is ready. I've already mentioned to you that we have something which we will deal with later, with looking shared resources. This is out of scope for today, and in the next episode we will go even further a little bit, because right now if I create an API, I mean a front end for this, and multiple people would try to play the game, then everyone guesses, it would increment the guess counter, and everyone would have the same number to guess. And if someone restarts the game, it would be restarted for everyone. So we need to do something, this API to be more stateful. And this is what we're going to do next time with a so-called middleware implementation. We will talk about what middleware is, how we implement middlewares, and we create our first middleware, which will distinguish between browsers by a session ID, what we will generate as a unique identifier. So this would be a deployable API, and multiple people in different places in the world could play this game with the same API call. Yeah, so I will see you in the next episode. Don't forget to subscribe to the channel if you would like to get a notification when I uploaded that one. See you. Bye.